Welcome back. This is an Aleks training video on elemental analysis. I would call this hard. There's many parts to this, and year after year, most of the class learns this, but you can't learn it in 1 second looking at your phone. You're going to need to pay some attention and do some work to try to learn it. Okay, this says that some kind of an analysis has told me that a sample of something that I have is 41.0% carbon, 4.58% hydrogen, and 54.6% oxygen. And they want you to determine what's its empirical formula. What is the ratio, like 1 to 2 to 1 formula for this material? Okay. So you may need to watch this video a couple times. Let me show you what I would like to do. First of all, I've got percentages. If I were to assume that I have 100 grams of the material, then 41% of 100 grams is 41 grams. Do you see? 41.0 grams. If I can assume 100, then it saves me a bunch of problems. I simply look at this number, and that's the number of grams. That'll be the number of grams. That'll be the number of grams. Because they all add up to 100, because it's a percentage. They all add up to 100. That means my grams would all add up to 100 as well. So if I assume 100 grams, then I'm going to have 41.0 grams of carbon. I'm going to have 4.58 grams of hydrogen, and I'm going to have 54.6 grams of oxygen. Okay. Now, grams doesn't really help me anything, because if I want a formula, say I have NaCl 1:1, if I knew that sodium was 23 and 23 grams and chlorine was 35 grams, knowing how many grams that I've got won't help me at all. I want a number. And if I could have a number, then I would be able to say, oh, that's 2 to 3 or 1 to 2, and I'd be able to get a formula. So I'm not interested so much in how many grams I've got. I want to know how many moles that is. Because a mole is a number. It's a really big number, but it's a number. So for instance, if I have 2 dozen chocolate donuts and 1 dozen vanilla donuts, I know that I've got 2 to 1 chocolate to vanilla. So if I can have moles of these, then I can say, oh, it's 2 to 3 to 2, and then I simply put those as subscripts and I'm done. All right, so I want to go from grams into moles, and to do that, I have to go through the periodic table. So how many grams is 1 mole of carbon? So 1 mole of carbon is how many grams of carbon? So I go to the periodic table, and it's 12.0107. 12.0107. Okay. What about hydrogen? In 1 mole of hydrogen, I've got how many grams of hydrogen? So I'll look, and it's 1.00794. How about oxygen? Well, this is not O2, it's just regular O. So in 1 mole of oxygen atoms, I've got 15, I'm doing all this from the periodic table, 15.9994 grams of oxygen. Okay, so grams of carbon cancels, grams of hydrogen cancels, grams of oxygen cancels. Now I'm in moles of all of this. Once I'm in moles, I can compare them. Okay, it's numbers. I have a 2 to 1 or a 5 to 1 or whatever. All right, so let me divide this out. I've got the first one, the carbon, is 41.0 divided by 12.0107. And I have 3.4136 moles. All right, let's go ahead and round to the same number of significant figures that I had. Okay, so I have 3 significant figures here. 41.0, that's 3. Let's round to 3. I have 3 here, 3 here. Let's round to 3. So this is going to be 341 moles of carbon. Okay, how about the next one? 54, nope, hydrogen is 4.58 divided by 1.00794. Okay, I'm going to take that to 3 places, and I've got 4.54 moles of hydrogen. And then oxygen, I have 54.6 divided by 15.9994. To 3 places is 3.41 moles of oxygen. Okay, now like this, I've got 3.4, 3.41. That means these are going to have the same number when I get to my recipe. When I get to the subscripts, these will have the same number, whether it's 1 or 2 or 3 or whatever. And this is going to be some multiple. Now, I can't have a half in a formula. It's not Na 1/2 Cl. It's always 1-to-1. H2O is 2-to-1. It's 1-to-1 or 2-to-1 or 3-to-1. So I'm looking at how many times this is bigger than this, because I want it at least 2 or 3 or 4. So what am I going to do? I know that if I take this number and divide it into itself, 3.41 divided by 3.41, I get 1. That's a whole number. What if I take 3.41 and divide it into this bigger number? So let's try this. Now, right now I'm in numbers. I just want to know what my multiples are. I want a 2-to-1 or a 3-to-1 or a 4-to-1. So I'm going to take the bigger number, 4.54, and I'm going to divide by the smaller number, 3.41. Okay? And I get 3.41 into itself is 1. 3.41 into itself is 1. 3.41 into 4.54 is 1.33. Okay? Well, I can't do 1.33. I need to have whole numbers as ratios. I need to say it's 2 to 3 to 2 or something like that. So what number do I multiply 1.33 to give me a whole number? Okay? Do you see that 0.33 is a third? It's a third of something. So if I multiply it by 3, then each of these thirds multiplied by 3 will give me a whole number, and at least I'll have a whole number. So let's multiply every one of these by 3. Okay, that's just a guess because I've got 0.33. If I multiply it by 3, 3 times this is a whole number, and 3 times this will be a whole number, and then they'll go together. So 1.33 times 3 is going to be 3.994, so I can just safely assume that that's a 4. Okay, 3 times 1 is going to be a 3. 3 times 1 is a 3. Now this is my ratio. Okay, notice that I started here with carbon. The next one was hydrogen. The last one was oxygen. So I'm going to put them in order, C, H, O, and I'm going to put the subscripts under them exactly as I see it. 3 carbons, 4 hydrogens, 3 oxygens. This is called the empirical formula, and it's the formula, it's the whole ratios, it's the ratio formula, 3 to 4 to 3. Okay? Really hard. Lots of steps, lots and lots of steps. But I hope you can see this enough. Do it, watch it more than once to where you can sort of do it. And do it after me. Try to do the same one I do until this makes sense to you. And ask me in class, I'll help you.